Good morning. Today, we're going to continue our work with triangles and talking about inequalities in one triangle. Our objective today, we're going to learn about inequalities in one triangle. You're going to be able to order sides and angles in a triangle when we're done today. Well, let's review the triangle exterior angle theorem that we learned about in Chapter 3. Remember that an exterior angle of a triangle is an angle that's formed by extending one side, such as angle D in this case. And remember what we learned in Chapter 3 is that the exterior angle, the measure of the exterior angle, is equal to the sum of the two remote interior angles. So in this diagram, angle D would equal angle A plus angle C. Well, today we're going to extend that corollary to the triangle exterior angle theorem. And it's simply this. Since you have to add the two remote interior angles together, the measure of an exterior angle is greater than the measure of each of its remote interior angles, such as in this diagram. The exterior angle would be angle BCD, and it would be formed by adding together angle A and angle B. Therefore, angle BCD is greater than the measure of angle A, and angle BCD is greater than the measure of angle B. Remember in the last chapter we learned about the isosceles triangle theorem, and that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. Well, today we're going to kind of work off of that with a little bit of a corollary as well. Remember that when we studied isosceles triangles, we did learn that the angles are opposite congruent sides. Well, they're also congruent. Today we're going to learn about angles that are opposite non-congruent sides. In two theorems today. And they're kind of converses of each other. If two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. So in our triangle here to the left in theorem 5-10, if xz is greater than xy, then angle y is greater than angle z. Again, your opposite angle is the angle that's not on either side of the side. And 511 is the converse of that, if you will. If two angles of a triangle are not congruent, then the longer side lies opposite the larger angle. So since angle A, formed by side AB and side AC, is greater than angle B, formed by BC and BA, that means BC, the side opposite angle A, is greater than AC, the side opposite angle B. Let's do an example. In problem 2, which corner of the triangular plot of land forms the largest angle? Well, notice that the triangle is a scalene triangle with no congruent sides. So if we want to find the largest angle, we got to find the angle opposite the longest side. And since AC is the longest side of the longest side, the angle opposite this side, angle B, is the largest angle. Take a look at problem 3. Which choice shows the sides of triangle LMN in order from shortest to longest? Well, we have the three angles ordered, so now we just have to work the three sides. Notice that angle N is the smallest angle. That means the side opposite that, LM, is the shortest side. Angle L is the middle angle, if you will. So MN, its opposite side would be in the middle of the order. And then angle M is the biggest at 65. So therefore, its opposite side, LN, is the longest side. And the answer choice would be C. More on triangles. In order for three sides to form a triangle, the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So if we look at our diagram of this triangle to the right, triangle XYZ, XY plus YZ would have to be greater than what? Well, the third side. In this case, XZ. YZ plus ZX has to be greater than the third side, XY. Finally, ZX plus XY would have to be greater than the third side of NYZ. A lot of times when I do the triangle inequality theorem, I use the two shortest sides compared to the longest side. Take a look at our final examples. Can a triangle have sides with the given lengths? Explain. Now, if we added 13 to something, since 13 is the biggest, we're automatically going to be bigger. So let's just deal with the shortest two sides. Can a triangle have sides with the given lengths of 6, 8, and 13? Yes, because 6 plus 8 is greater than 13. Again, if we added 13 plus 8, well, they're already bigger than 6, and we're adding things together, so they're going to be bigger. Just do the two shortest sides compared to the third side. Can a triangle have sides with the given lengths of 3, 9, and 12? Well, if we added together the two short sides, 3 plus 9, we would not get something greater than 12. So no, 3, 9, and 12 would not form a triangle because 3 plus 9 is not greater than 12. The other thing I expect you to be able to do, two sides of a triangle are 7 inches and 9 inches. What is the range of possible lengths of the third side? We need to set up two inequalities. X plus 7 has to be greater than 9. We're letting the third side of the triangle just be x. Therefore, x has to be greater than 2. The other triangle inequality we need, 7 plus 9 has to be greater than x. So 16 would have to be greater than x. So if we think about it like a range, 2 would be less than x, which would be less than 16. And thus, we finished lesson 5-6 on the triangle inequalities, and you can now go ahead and head to Math Excel and do the new assignment that's posted there.